Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems for actuarial exams is at smarturl.it/pass actuarial exams. And here you have information about online seminars for exams P, FM, IFM, and LTAM that I teach. In the first link, you go to smarturl.it/btdt-online. If you read my advice on how to pass actuarial exams, you know what BTDT stands for. Whenever you take the test, anytime you look at the problem, you should be able to say, been there, done that. That means you know immediately what to do. There is no time for thinking on the exams. Thinking is the last resort of the unprepared. You have to know immediately what to do. All the thinking is to be done before the exam. That's why I'm showing you these problems, so that you do the thinking now. On the exam, you need to know what to do immediately. And you also have links to the study manuals for exams P, FM, IFM, and LTAM that I wrote. You can purchase them at these websites. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. And if you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today. A piece of equipment is being insured against early failure. The time from purchase until failure of the equipment is exponentially distributed with mean 10 years. The insurance will pay an amount X if the equipment fails during the first year and will pay 0.5X if failure occurs during the second or third year. If failure occurs after the first 3 years, no payment will be made. At what level must X be set if the expected payment made under this insurance is to be 1,000? And here's the solution. So let's write T for the time from purchase until failure of the equipment. We know that T is exponentially distributed with hazard rate equal to 1/10, lambda equal to 1/10, because we are told that the mean of T is 10. And the mean of exponential distribution is the reciprocal of its hazard rate. And the density of exponential distribution is that lambda times e to the minus lambda t. We'll use that later. So in this case, is 1/10 e to the minus 1/10 t. Let P be the payment under this insurance contract. So it's X for t between 0 and 1, and X over 2 for t between 1 and 3, and 0 for t more than 3. And what we want is to find X such that 1,000 is equal to the expected value of P. But we can calculate the expected value of P. That's equal to the integral from 0 to 1 of X over 10 times, X times 1/10 times e to the minus t over 10. So it's X times the density, dt. And then the integral from 1 to 3 of X over 2 times the density, which is 1/10 e to the minus t over 10 dt. Okay, so we calculate the first integral as minus x, as indefinite integral. It's equal to minus x times e to the minus t over 10. Now remember, x is a parameter here in a sense. It's not the variable. The variable is t. So we're doing the integral with respect to t. You see that by looking at it and noticing that it says dt. That tells you the integral is with respect to t. So what's the integral of 1/10 e to the minus t over 10? And what's the function whose derivative that is? And it's minus e to the minus t over 10. And of course x is like a parameter, like a constant, so it stays there. And so we evaluate this minus x times e to the minus t over 10 from 0 to 1. Well, when t is 1, and this becomes minus x times e to the minus 1 over 10. And when t is 0, this becomes minus x, but it's subtracted. So it becomes plus x, because e to the 0 is just 1. And then the second, well, it's a very similar thing. It's x over 2 instead of x, but otherwise it's the same type of function we're integrating. So it's minus x over 2 e to the minus t over 10, evaluate from 1 to 3. And the value at 3 is minus x over 2 times e to the minus 3 over 10. And we're subtracting the value at 1, which has a minus in front, so minus minus cancel, become plus. X over 2 times e to the minus 1 over 10. And if we combine the like terms and factor out x, we will get this to be equal to x times 1 minus 1 half e to the minus 1/10 minus 1 half e to the minus 3 over 10. And that's approximately equal to 0.1772 times x. And because this is supposed to be equal to 1000, x has to be 1000 divided by this approximate 0.1772, which is approximately 5644, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.